J'aimerais appeler sur scène Cosimo Masini, qui représente l'entreprise DND Biotech, qui est venu visiter tout droit d'Italie Crisalid il y a de ça quelques mois, et qui serait donc intéressé pour installer un pilote. Donc, il va nous expliquer en quoi ça consiste. Et donc, nous tenions à le saluer aujourd'hui et à lui donner la parole, parce que c'est aussi intéressant de voir d'un point de vue de start-up qui ne rentre pas forcément en association, ce que Crisalid peut apporter. Merci beaucoup, Cosimo.
Merci.
Je vous en prie.
Ah, ça va. Bonjour à tous. J'ai 3 options. Alors, je peux parler en italien ou en italo-français, mais j'ai jamais fait ça en public. Et si vous me permettez, je vais parler en anglais. J'espère qu'il n'y a pas un problème. So, thanks a lot. When I first came to visit the Crisalid project, a few months ago, I was invited by Gael, Maxime, and Lydia. I was really struck by the project itself, by the beauty of the project, and how in line it was with our philosophy. I really found interesting the fact that it's a public-private partnership, and I think that's it's crucial. Because when you think of brownfield redevelopment, you really need to have all the stakeholders involved. Otherwise, it's not going to work. They're complex projects. They need to be well thought and planned in order to really have success. Otherwise, it will not work. And also, I really liked what I call holistic approach, in the sense that the project is not only focused on decontaminating certain contaminants like PCB, but really taking into account the ecosystem and the biodiversity of the soil. So this really is in line with what we do. DND Biotech is actually quite a young startup. We were born in 2019, but we actually come from a long way. We've been involved in remediation projects for a long time, and about 10-15 years ago now, I would say, we really started to focus on biotechnologies for soil recovery, rather than using other techniques, more like, for example, more physical, chemical, thermal. So we really started to focus and study the biology, the biochemistry, the geology of soil, in order to find a more sustainable approach. And we've been always keen to understand what's going on underneath our feet, not only for industrial sites, but also for agricultural sites. Just on a side note, I have a winery myself in Tuscany, and you might think, okay, that's nothing to do with decontamination and industrial site, but it has to do with soil. And for us, we are, mad about soil. So we've always been studying the science of soil, whether it's for production purposes, whether you're growing crops, whether it's for decontamination purposes. But in the end, the science is the same. So we were lucky enough, we have done our work in order to win some European projects, LIFE projects, Horizon projects, related to the study of the microbiome of soil, related to the study on how to remove organic pollutants from soil. So all this experience eventually emerged in the DND Biotech. So our approach really is, let's say, a 2-step approach. So the first part is really, as I said, focusing on the study of the microbiome of soil with molecular techniques, mainly metagenomics, in order to really understand and identify which microorganisms, bacteria or fungi are present in a soil that is contaminated. If they're present, it means they are capable to survive in such a harsh condition. So in our opinion, they are the best candidates to strive and eventually remove the contaminants, because they feed on these contaminants are their sole carbon source. So this is why we focus on autochthonous species. And once we have identified them and isolated them, we reproduce them. So we say we bioaugment them in order to put them back in the soil, inoculate them back. And in this way, we can accelerate the biodegradation. So it's not only a matter of biostimulation, but also in controlling and accelerating this process. Once we have done this, we engineer systems that are capable, depending on the local conditions, on bringing back, let's say, this species into the soil, whether it's in situ, whether it's on site. We have different configurations. We use prototypes, we use pilot plants, but the key message is, okay, nature can do its job, but if we help nature do its job, nature can do it in a better way, in a faster way, in a more controlled way, which means a better control of remediation time, reaching target criteria, and in the end, giving more certainties and guarantees both to clients but also to regulators. And this is quite important because we have noticed in the past that sometimes this kind of approach related to bioremediation left some doubts in regulators, in clients, so not always it has been chosen as the preferential one. On top of this, as I said, we don't only focus on removing the contaminants, but also restoring the biodiversity of the soil. And we do this by eventually adding amendments. We use natural minerals. We use zeolites, just to name a few. We can modify zeolites with microorganisms. But again, we tend to have this holistic approach in order not only to remove the contaminant, but to restore the ecosystem and the balance of the soil that can then be reused, whether it's industrial, whether it's for urban purposes, whether it's for revegetation, or whether it's agricultural soil. Just to name a couple projects that we are doing, we are starting nowadays as support. I mean, we are not the main actor and contractors for the biggest remediation project in the world, which is taking place in Kuwait. And this is related to the Gulf War that took place in the 90s. So their idea is not only to remediate millions of cubic meters, but also to do revegetation because of climate change, because of the need of greening urban and suburban areas. So again, one example of not only doing decontamination, but also focusing on how to bring back vegetation after the remediation has taken place. Agricultural soil, we've been part of a big European project related to a pesticide which is called lindane, HCH. I don't know if you ever heard of. And there are some very big sites in France, in Germany, in Italy, in Spain, where obviously there's a problem with concentrated sources that needs to be removed, but also highly diffused contamination, not only in soil, but also in groundwater and sediments. And we are using the same approach in order to isolate candidates that can be able to degrade this contaminant, but also restore biodiversity. And we're talking again about thousands of cubic meters, if not more. So there is this need for a more sustainable approach, because conventional techniques, they cannot work for the purpose. So the idea that we discussed with the Crisalid team was really to bring our mobile units. I don't know if there are some pictures, maybe not, but they can be seen in our website. I think they were in the initial presentation. Yeah. So really, it's a sort of a mobile unit that can be loaded on a truck, basically, and it can be used and deployed anywhere in the world. And we call it soil testing facility. So it has all the features in order to initiate a bioremediation process. So the idea is to bring it on site. There it is. So we have a fixed facility and we have these mobile units. and they're, as you can see, they're truck mounted. And within these units, you have what we call a terrestrial drone, which is basically a unit that can be programmed. It's fully automatic, and it's made for on-site aerobic biodegradation. And on top of this, we have fermenters, and we have units for nutrients, for mixing nutrients, basically in order to get a recipe, let's say, that can be then inoculated in the soil. So the idea is to have batches of soil from the site, from the Crisalid site, that can be tested within the unit. And in parallel, we can do everything that I explained before related to the analysis of the soil, mesocosm setting in order to test and understand which nutrients can be added, which amendments can be added, and all of this, again, in a controlled system, because the idea is to act like a bioreactor. We've been using biopiles, land farming for many years, but as I said, they're not as effective as a controlled system. So if you have a system where you can check and control humidity, temperature, pH, and many other things, you will have a much better control, which means in the end achieving the results in a more efficient way. So we think this is crucial for this kind of projects. There is also the option of having photovoltaic panels, which also means making the system self-sufficient, again in line with being more sustainable from an environmental point of view, energetic point of view, and in the end also a cost point of view, which is also very important. The last photograph, it's not very visible, but basically that's as an in situ bioflushing system to test our solutions in the saturated zone, whereby nutrients and inoculants can be flushed and circulated within these systems. And again, we can monitor and follow the remediation process accordingly. So what to say? I think Crisalid is a great fit for our solution. It's a perfect project. We have already some experience on PCB, so we can't really wait to start. And I hope the results will be very promising. So thanks a lot again.
Merci beaucoup. Alors, si vous êtes... Attendez, ne partez pas si vite. On va vous laisser, alors c'est pas un associé de Crisalid, mais malgré tout, on voulait lui laisser un petit souvenir, parce qu'il vient de loin. Donc merci beaucoup d'être venu aujourd'hui, et merci de vous être exprimé sur DND. Merci.